Hey folks, I'm Eric from LangChain, and today we're going to be building a search-enabled chatbot with Exa, which launched today. Um, let's get started. To begin, let's go through the main pieces of software that we're going to be using. To start, we're going to be using LangChain. LangChain is a framework for developing LLM-powered applications. Um, it's the company I work at, and it's the framework we'll be using. We'll be using the Python library, but we also offer a JavaScript library for folks building in that language. The second thing we're going to be using is Exa. Exa is a LLM-focused search engine, which allows us to retrieve results from the web to provide additional context for our generation chatbot before giving you your results. LangSmith is what we're going to be using for debugging and observability today. It is the first-party observability tool built by us at LangChain. We're going to be using it to inspect some traces, and we're also going to be using the Hosted Langserve product, which is part of LangSmith, in order to host our application in the end. We're also going to be using LangServe, kind of as previously mentioned. It is an open source package that allows you to host your chains as REST endpoints, we're going to be using the hosted one as well within LangSmith. Let's dive in. So first, we're going to be building our chain in a Jupyter notebook. Then we're going to be porting that over to LangServe as a REST endpoint. We're going to be playing with that in the playground that's provided there. And last but not least, we're going to be hosting that in LangServe in order to get it accessible from anyone on the internet. So let's dive in. So for our notebook, I'm just going to be using the Jupyter notebook in my VS Code instance. First, we're going to want to install some of our dependencies. As some of you may have noticed, we're starting to split out the package into multiple smaller partner packages as well. So today we're going to be pip installing LangChain core, which offers, we're going to be mostly using the runnable utilities as well as prompts from there. We're going to use LangChain OpenAI in order to use the GPT 3.5 model for our generation. You can obviously install any other LLM into this application as well. And last but not least, we're going to be installing the brand new LangChain Exa package, which is going to give us our retriever, which allows us to kind of search the web. The LangChain Exa package also offers some tools which enable agents to have search capabilities as well. But for today's generation use case, we're going to be using the retriever. Once you have that installed, we are going to set some environment variables. So to do that, we'll have OS and we'll set our OpenAI API key and our Exa API key. I already have these set in my environment, so I'm not going to fill this out for y'all today. But you can provision your own OpenAI API key at platform.openai.com, and I'll link the Exa docs on how to get your own Exa API key with some free search credits on it as well to this video. The other thing that we're going to do is we're going to set some environment variables that enable us to use LangSmith. LangSmith is in private beta at the moment. Feel free to DM me in order to get access to it. So in order to do that, we are going to set the LangChain tracing v2 to do that, we're going to set the LangChain tracing v2 environment variable. We're going to set our LangChain API key, and we're going to set our LangChain project as well. The last step is optional, it just allows us to find the traces for what we're doing today a little bit easier. And most importantly, we're going to build our chain. So the rough architecture of today's chain is we're going to first take some sort of user query. We're going to search Exa to get some documents related to that. Exa has this great feature we're going to use called highlights, which kind of summarizes the highlights from any of the sources it retrieves. And so we're going to be able to plumb those into an LLM. We're going to kind of wrestle with formatting that prompt in a way that the LLM understands well for a little bit. And then we're going to pass that into the LLM for generation. So to start, let's actually just play with Exa a little bit and see what that looks like. So we can import our retriever from the LangChain Exa package. We're going to be using the retriever today. Let's just use the default settings and see what documents we get from that. So we can just run retriever.invoke of best time to visit Japan. And if we inspect those, or inspect the first one, we can see that we have some content, which is actually going to be the entire page content of that website. So it's going to be rather large. And we'll also have some metadata on that document. And so here we'll have some like kind of page titles, URLs, as well as if we pass the highlights feature in, we'll actually get some highlights as well. So let's pass in highlights as true, and then let's actually only get the 3 most relevant results, just so we can save some of our Exa credits. So here we'll now see that we get this highlights array, which is going to summarize kind of the main points of this page. So we're mostly going to be using that highlights field as well as the URL, since we want our generation bot to cite its sources in the generations it does. So with that, let's try to create some sort of retrieval chain, which is going to format all of those outputs in a way that we want to pass it to the LLM. So the kind of first step of that is we're going to run our retriever. And just to keep it clear, we can define our retriever down here as well. Keeping the kind of final output in a single cell makes it a little easier for us to convert this to a LangServe application at the end. We'll also want to format this with a prompt template. So let's import that as well from LangChain core.prompts. And we can import other things as we go on. So first we're going to start with our retriever. Then we're going to want to format that list of documents in some sort of way. So let's pass that into some sort of documents chain or single document chain, and we'll have it operate on each element of that list. So we can kind of call .map on that, and let's define that up here. And so the assumption here is the input is going to be that single document. Here we'll have this be a runnable lambda, where we'll take that document and we will pass back the highlights as well as the URL of that document. So here we'll have document.metadata highlights and document metadata URL. And we'll need to import our runnable lambda as well, which is going to be from LangChain core runnables. Import runnable lambda. And then the next step is we're going to want to format this with some sort of prompt. So let's pass this into our document prompt, which we can define up here as prompt template from template. And here let's actually just wrap the whole thing in XML tags, just because it'll allow the LLM to kind of isolate information from the inputted documents a little bit better. And then we can include the URL and the highlights. And in this format, the highlights are going to get passed in as a list of strings. That's probably okay. If we wanted to make this a little more intense, and we can do this later, we can actually split those out into different sections. But because all the highlights come from the same URL, this is probably okay for the point of our application today. So that kind of forms our document chain, where at the end of this, we're going to have a list of prompt values, which we can use downstream. And then let's then combine all of those kind of source information contexts with another Lambda, which is going to take all the docs, and we're going to want to join some sort of list of these. So we can do the text of each of those prompt values for each of those documents. So let's see what we actually get from that. It looks like we are missing a comma somewhere. Because a string object is not callable. It looks like here I should have called backend.join this. And we can see that we're getting kind of a single string back with our 3 sources, as well as the highlights of each of these sources, where it's recommending public holidays, the most romantic time of the year, and the rainy season, which is quite interesting. But now we kind of have our retrieval chain, which we can use in our broader chain down here for further processing. So our overall chain is actually going to take a very similar format to a general RAG chain, where we're going to have some sort of runnable parallel to start. We're going to want to start with plumbing through the query, which is just going to be a runnable pass-through. This is going to just pass the user's query onto the next step through this query key. And then we're going to want to pass some context, which will be our retrieval chain. Then we'll want to pass that into some sort of generation prompt, which is going to take the query and context and format it for the LLM. And then we'll pass that into our LLM. So let's fill this out a little bit. So first we'll add some imports. We'll import our runnable pass-through and our runnable parallel from LangChain core. We'll define a generation prompt as, and let's do this one as a chat prompt so we can use a chat model for the LLM. So we'll use a chat prompt template for messages. And we'll have some sort of system prompt, as well as the content, which we can fill out in a second. We'll need chat prompt template for that, which Copilot is quite nicely supporting for us. And then we'll just use the default chat OpenAI, which uses GPT 3.5 Turbo. For our LLM. So we can import that from LangChain OpenAI, import chat OpenAI. This is kind of the new format of importing from some of those partner packages. Cool, so let's fill out our prompt. So let's tell our LLM that you are an expert research assistant. You use XML formatted context to research people's questions, and then we'll actually format this query that we're going to ask down here, where we're going to say, please answer the following query based on the provided context. And we'll pass in our query, add a little separator, and then continuing with some of the XML tags, we can pass in our context here, which is just going to be this, some form of this string up here, which is going to have multiple sources. Let's also add an instruction to please cite your sources at the end of your response. Cool. So now we have our chain defined. Let's see if we're able to invoke it. And we'll continue with our same question. And it looks like it's giving us a nice and long response, detailing some things, and hopefully at the end, it'll have some sources of what it used to generate that. So now that we have that constructed and tested, let's actually go back to LangSmith and see what it generated for us. So here in LangSmith, we can see the default view is going to show us the most kind of relevant pieces of the trace. So in this case, because it's a retrieval augmented generation bot, it's going to be our retrieval step, such that we can inspect which documents it's actually retrieving here, as well as the LLM call. So we can see what prompt we're actually passing in. So we can see that we're formatting our contexts and sources properly here, which is good, as well as the output from the LLM at the end. If you want to inspect kind of what's happening in each of those runnable Lambda steps, you can inspect further and see that the inputs to each of those kind of Lambda steps is going to be one of those documents, and then we're outputting like the highlights to URL segment, and then formatting that with our prompt template, if you recall from when we were constructing it. So now we have kind of our fully constructed chain for our search-enabled chatbot with Exa. And now let's convert that to LangServe. So to do that, we'll go back to the S code. And here, we're going to start with installing the LangChain CLI. We'll just do this in a terminal down here. You can just install, recommend running it with upgrade in case you already have it installed from either using LangChain templates or something else. You can just run install upgrade LangChain CLI. Then you can run the LangChain commands. So first we're going to initialize our app with LangChain app new. I'm just going to create it in the current Perplexity directory. If you give it a name, it'll just create a directory within that. We will skip adding packages just because we're going to paste in a chain that we have defined up here. The packages are just LangChain templates. And then we can see that it has bootstrapped an application for us with a Docker file, PyProject TOML, a README, as well as an app directory and a packages directory. We're actually not going to be using the packages directory. As mentioned, that's for LangChain templates. And we're just going to be playing in this server.py file in the app. So first, we're going to add some dependencies. I use Poetry for my dependency management. It allows it to automatically update this PyProject TOML file, which is quite nice. We're going to install the same set of dependencies that we had in our Jupyter Notebook. So we're going to Poetry add LangChain core, and we'll see that show up in the PyProject TOML. And then we're also going to add LangChain OpenAI and LangChain Exa. I'll add those and then be back in a second. And now that we have our dependencies installed, also added the command to the Notion doc over here just so it's easier to follow along. Now we will copy our chain over into our application. I like keeping the server.py file a little bit cleaner in order to just keep the fast API kind of app logic separate from the LangChain chains. So let's actually just define a chain.py file next to this where we can paste in our chain from this other document. So I'm pretty sure I can just paste in these two cells, and we'll remove the invoke in the middle. So first we'll define a retrieval chain, and then down here we will define our regular chain. And we can even put all of our imports together up here to keep VS Code a little bit happier. And we'll save that file, and now our chain should be accessible from our server file. And then by default, it doesn't have any routes defined, but it gives you this nice little stub. And so we'll actually just add that chain, which we'll import from app.chain, import chain, because we have it in chain.py as well as chain is the name of our variable. And then that will just host this endpoint at the kind of default / endpoint. If we want, we can define a path as kind of / search or something like that, which could be kind of nice. So we've copied the chain over, we've added the routes, and now we can serve it. So let's poetry run LangChain serve and see if that works. Hopefully I remembered to add all the dependencies. And if you get this message, you're probably in business. So from here, we can see that we're hosting it on port 8000. So we can click onto that. By default, it'll show us the stocks page. But we want to go to the search playground. Right now, it's telling me that there is no applicable renderer found, which is too bad. Let's go back to our chain and see if we can add a type definition for the input, where here we have our input type set just to a string, and see if that does anything for us. And perfect. So now we can see that we get our input as a string. Generally, LangServe will try to detect the defined input type for our input over here. I think it got a little bit confused because the input of our runnable pass-through and our retrieval chain could be something other than a string or some sort of formatted dictionary. And so we had to define our input type as a string. If you want to pass in multiple pieces of the input, you are welcome to define this as like a pedantic base model, which we can play with in a little bit if we want. So here, let's try when is the best time to visit Japan. And we can see in the LangSmith playground, it actually will show us kind of the individual steps that it's running as part of this. So right now it's kind of running through the retrieval step before passing it all through to the LLM. It's taking a little bit of time so we can check our stack trace. Right now it is telling me that I am using a wrong API key. So let's try adding my API keys to my environment again and running LangChain serve again. And then we can try this again. And that looks to be going better. So we can see that it ran the intermediate steps for retrieval. And then in the playground, we actually get streaming output as well, which is pretty good. So here we get kind of a guide for why it might depend on several factors. Let's ask specifically for a ski trip and see if it gives us a more concrete answer. And here it does. And it starts planning our trip as well, figuring out which ski area we're going to go to. The other nice thing about LangServe is even when using it hosted locally like this, we will actually see these traces show up in LangSmith as well. So here, because the playground is using streaming output, the only difference is the output is going to be kind of some sort of chunked output, but LangSmith handles that pretty well in terms of displaying that to you. And overall, our trace actually looks pretty similar, where we can see kind of the prompt that's actually formatted in the Chat OpenAI step, and we can even see which documents are actually plumbed through. One note is this app that we build is just using the highlights that are given to us by Exa. If you want, you can also operate on the entire page content, but the Exa highlights work pretty well and they save you a lot of tokens. As mentioned earlier, if you want access to LangSmith, feel free to DM me and I can get you access to that. Okay, and then last but not least, we're going to host our chain in Hosted Langserve. So Hosted Langserve is this deployments tab in LangSmith. Right now, I don't have any deployments in my in this account. So we can go over to new deployment and see kind of what steps it wants us to do. We'll name our deployment. So here we'll have this as perplexity, emphasis on Exa, and then we'll want to import our repository from GitHub. So in this case, I'll actually just deploy this project to just a public repository. You can also deploy private repos, and that all works well too. So here we'll want to initialize our repo. We'll see what it is going to try to commit. Just in case we've created any of these PyCache folders, let's actually create a git ignore where we already have PyCache in there. So let's try adding everything and see what files it's going to add. That looks pretty good. And we can commit that project there. I'm realizing I'm using a local development version of the Exa package because it's not published yet. So I'm going to fix that and be back in a second. Okay, I fixed that dependency. That will not be a problem for you because you'll be using PyPy dependencies. If you do ever use kind of local development dependencies in your application, you will have to either make those Git dependencies or publish them to PyPy in order for Hosted Langserve to be able to download them, unless it's kind of within the same directory. So let's commit our project, and then we can create a repo. We'll push our existing local repository. We'll call it T LangChain perplexity. We'll push it to just my personal eFreeze, don't need a description, and we'll make it public. We can add the remote as origin, and we will push our local commits to it. Cool. So now we can go over to GitHub and see if that is properly showing up as LangChain perplexity, and looks like we are in business. So if we go back to our deployments, we can import that repository from GitHub. We'll give it access to LangChain perplexity, and we will authorize. And we can close that. Back here, we can see that we have access to that repository. If you give access to all your repos, you'll just be able to select that here. It's stored in the root of the directory. We're using the main branch, and we'll need to set some environment variables. So here we're going to want our OpenAI API key. We're going to want that to be a secret, and we're going to want our Exa API key as well. I'm going to populate those two and be back in a second. Okay, now that we have those environment variables set, we can submit our deployment, and Hosted Langserve will kind of take over from here. It'll provision a machine for us. Hosted Langserve is very well integrated with LangSmith, such that all of our traces will actually populate in its own project over there, and we'll be able to see all the traffic that comes into it through the hosted endpoints here. For Hosted Langserve, this is also in private beta, and if you would like access to it, feel free to DM me about that as well. So we set our environment variables, and I'll kind of cut out the section where this is deploying, and then we can test it in the hosted playground. Okay, and now our Hosted Langserve application is deployed. We can see our deployment shows up here. We can go to it, we can see that the docs for it are showing up, and we can even go to our same search playground endpoint and see if we can ask a question such as, when is the best time to visit Japan for the cherry blossoms? And we get a result. In recap, today we went through building kind of a search-enabled chatbot with Exa using LangChain, Exa, LangSmith, and LangServe. We started by developing our chain in a Jupyter notebook. That was kind of where the bulk of the LangChain specific logic was. Then we ported that over to a LangServe application using the LangChain CLI. And kind of monitored what was coming out of that through LangSmith traces. And last but not least, we deployed our LangServe application in Hosted Langserve, also a beta product, as part of LangSmith. Again, if you want to get access to the private beta of LangSmith or Hosted Langserve, please let me know. And thanks for listening. Bye-bye.